The fatal crash rate for large trucks has declined significantly during the past decade, even though the number of miles driven has increased by 36%. Despite these improvements, there are nearly 400,000 crashes involving large trucks in the U.S. each year, resulting in about 5,000 fatalities. Research shows that as many as 70% of those fatalities are caused by the actions of other vehicles rather than trucks. The Federal Motor Carrier Safety Administration has produced this video to teach the drivers of passenger vehicles some important survival skills: how to avoid crashes with large trucks. Trucks make up about 8% of all vehicles involved in fatal crashes. However, these crashes result in 12% of the total number of people killed on our nation's roads and highways. The disproportionate involvement of trucks in fatal crashes is a reflection of a fundamental law of physics, which is expressed by the equation kinetic energy equals 0.5 times mass times velocity. There is no way to avoid the fact that all of the kinetic energy generated by moving vehicles is dissipated in a collision by friction, heat, and the bending of metal. The more kinetic energy in a collision, the greater the potential for injury to vehicle occupants. Trucks typically weigh 20 to 30 times as much as passenger vehicles. In a collision, the greater mass of a truck transmits more kinetic energy than a passenger vehicle, which places the occupants of the passenger vehicle at a considerable disadvantage. 95% of the fatalities in these crashes are the occupants of passenger vehicles. That's right, 95%. Clearly, when big and small collide, small loses. The disadvantage to smaller vehicles that results from differential mass is compounded by speed. Kinetic energy increases by the square of the vehicle's speed rather than by speed alone. For example, a 30% increase in speed, say from 50 to 65 miles per hour, results in a 69% increase in kinetic energy. For this reason, the probability of injury and the severity of injuries that occur in a crash increase greatly with vehicle speed. Most people believe that because trucks are big, they must have terrific brakes. Well, they do, but they can't stop a large truck nearly as quickly as a passenger vehicle can stop. When a trucker slams on his or her brakes, air must travel through a hose for about 40 feet to reach a valve that releases more air under pressure to operate the mechanical portion of the brake system. The pneumatic and mechanical lag results in a delay of more than half a second, compared to the nearly instantaneous hydraulic connection in a passenger vehicle. Trucks simply can't stop as quickly as passenger vehicles. For example, a car traveling at 55 miles per hour can stop in about 160 feet. But a large truck traveling at the same speed can take more than 240 feet to stop, nearly the length of a football field.
When we try to apply our brakes, a lot of depends upon how much weight we're hauling. If we're empty and we put these brakes on, we can literally almost stop on a dime. The brakes are very, very strong. But fully loaded, it takes probably 3 times the distance to stop one of these as it does a car.
Truck drivers try to follow other vehicles at a safe distance. But when a passenger vehicle cuts in front of a truck, the safe stopping distance is gone. The disproportionate number of fatalities resulting from truck crashes and the disproportionate representation of passenger vehicle operators among those fatalities create the perception among many motorists and some law enforcement officers that truck drivers must be disproportionately at fault. However, the statistics show that drivers of passenger vehicles, rather than truck drivers, are responsible for most of the crashes involving passenger vehicles and large trucks. Ignorance of the performance limitations of large trucks appears to be placing a large number of motorists in very dangerous situations. In response